Next, we are going to look at surface area of cylinders, which is 12.3 in your textbook. Again, surface area is the area covering the entire object that we're looking at, which in this case is a cylinder. So here's our surface area formula. This is found on your Keystone formula sheet. So we're looking at this first formula here, surface area. 2 pi r, which is a radius, squared, plus 2 pi r h, and h is symbolizing the height of the cylinder. So let's look at our first example. So we want to know the surface area of the cylinder pictured here. We are going to round to the nearest tenth. So surface area is 2 pi r squared plus 2 pi r height. So in this picture, the radius is 14 and the height, which is going to be perpendicular when it's pictured, is 18 feet. So let's substitute in. So 2 pi, the radius is 14, squared plus 2 pi times 14 times 18. And when I simplify this, I want my final answer to the nearest tenth, but I'm going to first start by simplifying in terms of pi. So if I do 14 squared first times 2, I end up with 392 pi. And then if I do 2 times 14 times 18, I get 504 pi. I can add those two answers together, treating pi just like these two are like terms. If I add them together, I get 896 pi. So that would be the exact answer of this surface area. I do want you to round your answer to the nearest tenth though, and so you can just type in 896 times pi into your calculator, and you get that the surface area is approximately 2,814.9 square feet. And that would be the approximate surface area of this cylinder. Let's do another one. So we're going to find the surface area of a cylinder with a height of 50 centimeters and a diameter of 27 centimeters. So here's one thing that I need to know, the height. If the diameter is 27 centimeters, the diameter goes the whole way across the circle. So we're just interested in the radius, which is going to be half of this diameter. So half of 27, and we'll use decimals here, is going to be 13.5. And we'll use the decimal just so it's easier to substitute in. So now we're going to find the surface area. So 2 pi r squared plus 2 pi r h. Substituting in 2 pi 13.5 squared plus 2 pi 13.5, and then this height of 50. And again, I'm going to express my answer in terms of pi. So if I do 13.5 squared times 2 first, I get 364.5 pi. And then if I do 2 times 13.5 times 50, I get 1,350 pi. So the exact surface area would be 1,714.5 pi, and rounded to the nearest tenth, that would be approximately 5,386.3 square centimeters for that surface area. Okay, now let's do a couple examples where we're working backwards. So here we're going to find the diameter of the base of a cylinder. We're given the surface area and we're given the height. So let's go ahead and write our equation, substitute in, and we'll talk about how to solve for the diameter. So surface area, 2 pi r squared plus 2 pi RH. So I know the surface area, so I'm going to replace that with 480 pi. I don't know the radius, so I'm going to leave that as r squared. That's actually what I'm going to solve for to help me find the diameter. So 2 pi r, and then the height is 8. So I'm going to simplify everything, and basically the only thing I need to simplify here is I'm going to multiply that 2 and that 8. So I get 480 pi 2 pi r squared plus 16 pi r. So first thing I'm going to do is I see that everything that I have here every term can divide by pi, and it can divide by 2. So I'm always going to start a problem like this by dividing everything by 2 pi. I know I'm going to eventually need to factor, so it's really important that I divide away that pi to help with the factoring process. So when I do 480 pi, notice all the pi's simplify. 480 then divided by 2, I'm left with 240 equals r squared, and then 16 divided by 2, 8r. This now is a whole lot nicer to factor than keeping the pi's and keeping the 2, so make sure you do that division by 2 pi first. So now I'm going to set it up to factor. So I'm going to get r squared plus 8r minus 240 equals 0. My two factors here, two things that multiply to give me negative 240 but add to give me positive 8. My two factors are going to be r plus 20 and r minus 12. So 20 times negative 12 gives me negative 240. 20 minus 12 gives me that positive 8. So then when I solve, I get that r is negative 20, or I get that r is 12. So this r is representing a radius of a cylinder, so we definitely don't want the negative answer. So this r is equal to 12. The radius is 12. We ultimately want to know the diameter though, so the diameter is twice that. The diameter is 24 inches. And you can always substitute that back into your formula, check and make sure that you get that surface area of 480 pi that you want there. Okay? And one last example, we want to find the height of the cylinder if the surface area is 291.1 square yards and the radius is 4.1 yards. So this time we're looking for the height given the surface area and the radius. So surface area, just writing out my formula first again. Okay, so substituting in for surface area, I'm going to put 291.1, 2 pi, they told me the radius is 4.1 squared. And then I want to know the height. So this one we aren't going to have to factor because we're just solving for height. So I'm going to go ahead and at least get this in terms of pi. So 4.1 squared times 2 is going to give me 33.62 pi, and then plus 8.2 pi h. Okay, and now I'm just going to solve for h, keeping in mind that pi is just a number. So I'm just going to solve this algebra problem like you guys are used to. I'm going to start by subtracting this 33.62 pi. Doing it this way will give us the most exact answer, and then we'll round in the end. So if I do 291.1 minus 33.62 pi, I should get 185.5. And then equals 8.2 pi h, and then I'm just going to divide by this 8.2 pi. Make sure when you divide by this 8.2 pi that you're putting it in parentheses in your calculator. or else it's not going to perform like order of operations correctly. So put that denominator in parentheses. And if you do that, you should get a height of 7.2 yards. And again, you can always substitute that 7.2 in, double check that that gives you that surface area that you're looking for. Okay, next we will be doing volume of cylinder, so stay tuned for that.